Welcome back to my hardest questions challenge. A vectors question for you today from paper 2, the higher paper in 2018. This was the hardest question according to student results. So we've got a vectors question here. So CDEF is a quadrilateral, as you can see. CD is little a, so I can annotate that. CD is vector little a. DE is vector little b. FC is a minus b. And we have to express FE, which is that vector there, in terms of A and B in its simplest form. So F to E would be achieved by going from F to C, C to D, and then D to E. So we can literally add those vectors together in the A and B term. So we go along FC first, that's A minus B. We then go along CD, which is just vector A. And then we go down DE, which is vector little b. Collecting like terms, A plus A is 2A, and negative B, add positive B, cancels, because it's a zero pair. So your answer for part A, for two marks, bit of a gimme, is just 2A. So very straightforward. However, the next part is where life gets significantly more tricky. Work out the value of n for this arrangement here. So we've got m is the midpoint of DE. So DE has this midpoint m. X is a point on the line FM such that it divides it into two parts, fx, and it's given as a ratio. Fx to xm is given as n parts to one part. Okay. We have to CXE is a straight line. That's really important, actually. That is really key to solving this problem. I'm going to put that vector in, that straight line, sorry. CXE is a straight line. Now, because n is used as the ratio within, let me go back to red pen. It's used in the ratio to divide FM. We can't just solely work on FM because we'll get nowhere. So what we have to do is see if we can involve a portion of FM in another calculation, right? And here's what I mean. So if you look at the vector CE in its entirety, so the line from C to E, which goes through X. Now CE in A and B terms is little a plus little b. That tells us a really key thing, that the coefficients, in other words, the coefficients of A and B would have to be equal, right? So if we then wanted to work out something like CX, it would be a fraction of CE, so therefore we would know what the coefficients, how the coefficients would relate to each other in CX. But if CX were to include, as it does, I'll show you in a second, a portion of the line FM or the vector FM, then it would then involve this part of its coefficient would involve the letter n. And then we'd know we would be heading towards the equality of the coefficients for A and B. So let me just flesh that out a bit. So CX I should say. CX is made up of CD plus DM plus MX. So that would be CD is A. DM, now DM, M is the midpoint of DE, so if DE was full B, DM would be half B. Okay, and then MX would be a fraction of MF. Okay, so it would be a fraction. Well, what fraction would it be? Well, it would be 1 part out of n plus 1 parts of MF. So it'd be 1 part out of n plus 1 parts of MF. Now MF is going to be ME, which is another half B, and then EF. Well, EF is just the opposite direction of FE, which is what we worked out in part A. So it will be, just to recap, we want MF, so we have ME, which is half B, and then minus 2A, which accounts for E to F. So if you look at that now, and just pause for a moment, we have this expression here, which is in terms of little a and little b. It involves the coefficient n, or it involves the value n, which is part of this ratio that we're trying to find. So if we actually work this out, we know that because Cx is in a straight line, that Cx is part of CE. Now CE is A plus B. So therefore, when we start to manipulate this expression for Cx, we can then say, right, the coefficient of A is equal to a coefficient B, and then hopefully we'd have an expression in terms of n, so we can then start to work out its value. Right, let's get cracking. So Cx, if you can see that, Cx is equal to A plus a half B plus, I'm going to expand this kind of bracketed term here. So 1 over n plus 1 lots of half b minus 2a. So we have 1 over n plus 1 multiplied by the half b minus 1 over n plus 1 times 2a. So I've basically multiplied 1 over n plus 1 by negative 2a. So it's minus 1 over n plus 1 lots of 2a. Okay, let's simplify this. So we've got a plus half b, and this third term here would then look like 1 over 2 lots of n plus 1 b, and then the fourth term would be minus 2 over n plus 1 a. Okay, next bit, let's combine like terms. So we have an a term and an a term here, so that would look like a minus 2 over n plus 1 a. Okay, you can put that in brackets if you like. And then I've got two b terms here and here, so plus a half b plus 1 over 2 n plus 1 b. Okay, so I'm going to factorise the a term from these two. So factorise the a will leave me with, I'm going to put the a second, a divided by a is 1, and this would be, this term here would just be 2 over n plus 1, and factorise the b from these two terms, put the b last, and this would be a half plus 1 over 2 brackets n plus 1. Let's make that into a single fraction, so this would be n plus 1 as a common denominator, n plus 1 minus 2, lots of a. Again, let's make a common denominator here. Just double check and work. Yep, okay, so this would be common denominator of 2 brackets n plus 1. So this first term here would be n plus 1, and then the second term would also be plus 1, and that would be lots of b. Okay, let's simplify numerators in both. So we get n plus 1 minus 2, which is n minus 1 over n plus 1. That's that many lots of a. Second term would be n plus 1, which is n plus 2 over 2 brackets n plus 1. And that's your coefficient of b. Okay, so this is Cx. Now, Cx is a fraction of CE, as I said before. So we're looking to see if it's a fraction of if it's a scalar multiple of essentially a plus b, then these two coefficients of a and b here must be the same. So what we can do, we can now set up an equation to say that n minus 1 over n plus 1 is equal to n plus 2 over 2 lots of n plus 1. Now this is what we've got to solve. So I can multiply both sides by n plus 1, and that will give me n minus 1 equals n plus 2 over 2. Just popping up here. Multiplying both sides by 2 will give me 2 brackets n minus 1 equals n plus 2. So 2n minus 2 equals n plus 2. Subtract n from both sides gives me n minus 2 equals 2. Add 2 to both sides gives me n equals 4. Now that is quite challenging at GCSE, and if you've managed to follow that, well done. I hope that helped. Thank you very much.